To do the two-way ANOVA, only looking at the main effects, I use this formula, and the rest is exactly the same. Yeah. So I do LM again. How can I see the ANOVA table? Well, exactly the same as what we have done for the one-way ANOVA. I use this function from the car package on the output of LM. The only difference here is that I'm setting the type. To explain this, I have to show you this. How does ANOVA work? Very briefly. ANOVA works by calculating a lot of sums of squares. For instance, I will just explain and then you will see where they come from. For instance, what ANOVA will do is it will calculate the overall average of all the groups. That's what you see here, this 24.7. The overall average, and then it will calculate the distance of each point for every group, for each point to that overall average. And these distances, he's going to square them, because if you don't square them, you have positive distances and negative distances, you end up at 0. Yeah? So he's going to square them. And he's going to calculate the sum of all these squared distances. That's one sum of squares. He's only also going to calculate this. So you still have the overall mean average for all the groups. And then in each separate group, he's also going to calculate the mean. So that's the mean for the red group. This is the mean for the green group. And this is the mean for the blue group. And then what he will do is he will calculate the distance of every point to the mean of its group. That's what you see here. So for the red, you get these distances. For the green group, you get these distances. For the blue group, you get these. And again, he's going to square the distances and calculate the sum, the next sum of squares. And then lastly, he's going to, for each group, he's going to calculate the distance between the mean of that group and the overall mean. So that's what you see here. For the red group, you get these distances. For the green group, you get these. And for the blue group, you get these. He's going to square the distances and calculate the sum. That's the third sum of squares that he calculates. Why is this important? Because it allows him to see if the groups are different. Because this here, this sum of squares, reflects the variability within the groups. The more variability inside the groups, the higher this sum of squares will be. So this is the variability within the groups. This here is the variability between the groups. The more the groups are different, the higher these distances will be. The higher this sum of squares will be. And what is he ultimately comparing? These two sums of squares. If this one is a lot bigger than this one, he can safely say, yes, there is something going on. Because the variability between the groups is way bigger than the variability within the groups. For one-way ANOVA, that's exactly how it works. That's how it's calculated. For two-way ANOVA, he's also making these calculations, but it's a bit harder because you have more groups and more grouping variables. So, for two-way ANOVA, you have 3 ways of calculating the sums of squares. The types. The thing that you define here, the type. Okay. Type 1, nobody uses it. It's not implemented in R, so nobody does this. So that leaves us with type 2 and type 3. What's the difference between the two? Type 2 ignores the interaction, while type 3 takes into account the interaction. When there is an interaction, you should go for type 3. Yeah? That's the correct thing to do. When there's no interaction, you should go for type 2 because type 3 is more stringent than type 2. So basically, concretely, what you typically do is you check if there is an interaction. If there's no interaction, you're going to analyze the data without interaction. and you ask for the type 2 approach. When there is an interaction, you ask for the type 3 approach. So, and this refers to what I write here. I'm not looking at an interaction here. I'm ignoring it, so I can go for type 2 here. There will not be a type 3. So when I do this, I get a p-value for gear and a p-value for transmission type. And you see that this is significant. So there is something going on with the gears. The groups for gear are different. Okay, I have 3 groups for gears, so I know that there's something going on, but I don't know who is different from who. How can I find which group is different from which? Exactly the same as what I did for the one-way ANOVA. It's exactly the same code. So I'm going to compare everything to everything using Tukey's tests. So here we go, and here we go, and here are the p-values.